Guys, stop breaking my game. I'm going to break your game. Uh-oh, I'm in trouble. So I was just more talking hate comments, sign up page breaking, new bugs popping up left and right, and requests for exercises that I've never even heard of. I mean, what the there's like a new follow. Guys, stop breaking my game. I'm going to break.
Is stereo madness possible with negative hitboxes? That's not even possible. Shut up, let me explain. If we go to the settings and disable fixed negative scale, we can kind of break the hitboxes and they turn it into a single dot. So alright, select all, bam. Dude, I swear to god, if this works, I don't know what I'm gonna do. Wait, what the hell? What? As you can see, we get some surprises sometimes. Wait, what? Oh, we gotta touch that little green dot. What the hell? Which means we can literally just completely ignore that Q portal and keep going through the level until we finally beat it. Possible! Is stereo madness possible with negative hitboxes? That's not even possible. Shut up, let me explain. If we go to the settings, yes.
Oh man, my day is ruined. Now I can smell like a bit of lalaki. Oh man, no one heard that. Let's get something to eat.
Uni.
Hey, delete that.
Uni ko na yan, ah.
guys hear me now? Okay, okay, there we go. All right, so my name's Lalit. Hi, everyone. I'm gonna be your your instructor for day one of the seminar. Why don't we all go around and I'll call you name one at a time, and you can tell everyone your name, what school you go to, and what's your favorite subject in math? Like maybe it's algebra, maybe it's geometry, something like that. It could even be really really specific. So we're gonna start here. Adrian, you want to start us off?
Wait, so it's name, school, and subject?
Yeah,
Yeah,
it's really casual. So okay,
my name is Adrian. I go to the King's Academy, and my favorite subject is geometry.
okay, that's nice. Euclid, you want to go next?
Sure. Okay. My name is Euclid. I go to Skinner North, and my favorite math subject is probably algebra.
Nice. And then Yanzhao, you want to go next?
Hello, my name's Shane actually.
Oh, sorry.
I
Okay.
go to Solon and my favorite subject is probably geometry.
All right, very good. Mono, you want to go next? Monil.
My name is Moniel. I go to
Okay.
Meadowbrook, and my favorite subject is probably geometry.
Geometry. Okay. And then Rudra, you want to go next?
Hi, my name is Rudra. I go to Canyon Vista Middle School, and my favorite type of math is algebra.
Nice. Okay. And looks like we have a couple more. Ashna, is that how you say it? Do you want to go next? Okay, um looks like they posted in the chat. They're Ashna, they go to WMS and they like algebra, okay? And then Hannah.
Hi, my name is Hannah. I go to Skinner North, and my favorite thing is math is probably algebra.
Oh, we have a couple students at Skinner North actually. Okay. And then I think the last person is Lizzie. If your mic's working,
My
yeah.
my name is Vincent. I go to Math Circle, and my favorite type of math is probably geometry or algebra.
Okay. Wow, so you guys go to a variety of schools, have a variety of interests. That's really cool. All right, so let's get started with the seminar. The way it's gonna work is there's gonna be a problem on the screen, and you guys can work through the problem. Do you guys know how to direct message me? Instead of like, can you guys send me a private message? Just I want to check if you guys know how to do that. So, everyone just try to send me a private message saying hi or something. And okay, it looks like I got four people. Waiting on a couple more, but oh, so like Lizzie, you sent hi, but you sent it to everyone. So try to start a new chat, and then if you click on new chat, you can click my name, which is Lalit. You'll see me like my videos on. So you'll see my name. Okay, got it from a couple. All right. I got it from almost everyone, but Lizzie, if you're having any, sorry, your name's not Lizzie. Is your name Vincent? Was that your name?
Yeah.
Sorry. Okay.
Wait, what's your name?
My name is Lalit. You can see it in the Zoom, in like the Zoom thing where you see your name. So do you know how to change your name?
No.
No? Okay. It's okay. I know your name's Vincent, so I'll just call you by that.
Okay.
Yeah, no worries. So, okay, let's just get started. I think as it works, you guys will understand what to do. Okay. All right, are you guys able to see my screen? Um,
Yeah.
you guys can, okay. Looks like people can see my screen. Okay. So this is day one, and let's get on with the first problem. So this is the first problem. You guys can probably should get out a piece of paper and a notebook and just try to work through this problem and send me a direct message when you got it. I'll tell you whether you're right or wrong, and I'll try to give you some hints along the way. If I think I know what you're trying to do. If you're also stuck, also just feel free to ask me any questions. So, but yeah. All right. So looks like a lot of people were able to solve this one successfully. If you didn't, that's okay. We're gonna go over it now. But for each problem, I'm gonna call on a person who got the right answer. What I want you to do is don't tell us how you did it step by step, but what was your overall strategy in solving it? So I guess for this problem, I'm gonna call Rudra. Rudra, what was your strategy when trying to solve this problem?
I use substitution.
Okay, so that's great. So we'll actually go with Rudra's strategy and we'll use substitution. There might be different ways you did it, faster ways, but let's just go through it. So what we have here is called a system of equations, and we're trying to solve for x and y. So if we use Rudra's method, then what's gonna happen is we're gonna isolate one of the variables. So let's say we want to isolate y here. We have 6x plus 5y is equal to 5, right? So if we subtract 6x from both sides, we're going to end up with 5y is negative 6x plus 5. And then we divide from 5 on both sides. And so we get y is negative 6, 6/5 x plus 1. Okay, so we have this for y. What we do here is we can plug this value of y into the second equation. So 4x plus 10y equals 6. So what I'm actually going to do is, to make it simpler, I'm going to divide by 2 on both sides. And so we're going to get 2x plus 5y is equal to 3. And we can substitute our value for y. So we get 2x plus 5 times negative 6/5 x plus 1 equal to 3. And so this is 2x minus 6x plus 5 is equal to 3. So negative 4x plus 5 equals 3. We subtract 5 from both sides. And so negative 4x is negative 2 equal to negative 2. And so x is 1/2. And the nice thing about substitution is we have a direct formula for y. So since x is 1/2, we can say y is negative 6/5 times 1/2 plus 1. And so, like many of you got, we got y equals 2/5. And so I want to mention something first. So a lot of you got y equals 2/5, x is 1/2, and you messaged these two values to me. But what the question is asking for is we want to find the sum of the real numbers, x and y. So actually the answer is 1/2 plus 2/5. And so we make a common denominator, which is 5/10 plus 4/10. And so we get 9/10. So the answer is actually 9/10 or 0.9. And so one thing to try to do is on the piece of paper you have, whenever you see a question, just write down the final thing you want to solve. So along the way, we found x and y, which is great. But the final thing we're actually looking for is the sum of x and y. So it's just a general strategy that helps prevent like silly mistakes. All right, that was pretty good. I think everyone got that question right. So let's move on. Okay, yeah, this is the solution. And this is the next problem. You guys give it a go. For each problem, it will take maybe anywhere from 2 to 5 minutes. So, well, based on how difficult it is, we'll see how fast everything goes. But yeah, this is the next problem. You guys can give it a go. So a lot of people are getting the answer of 24. And let me go through, I think what you guys are trying to do and what you might be missing. So it's a 12 centimeter by 13 centimeter pan, and we have 2 centimeters by 3 centimeters. So I think what you guys are trying to do is you're taking 12 centimeters, and because you know it has to be a whole number of brownies. So you're doing 12 centimeters. Oh my God, sorry. So I think I'll just go over the solution. So we're taking 12 centimeters and then we're dividing it by 3 centimeters to get 4. And then 13 centimeters, if we divide it by 2, we get 6.5. But then we have to make it 6, right? Because there can't be too many. So we get 4 times 6, which is 24, which should be right. But if we actually draw it out, what we see is that this is what we're doing. We're doing, and then we have like a 2 centimeter, two, two. And so if we shade in all these brownies, what a lot of you guys are saying is that this is 24 brownies. Um, and so that must be the greatest number of ways to do it. And some of you are saying 26. And so actually the right answer is 26. Let's go over why it is 26. So instead of breaking up the pan this way, the first thing we notice is that let's just try to do, let me use a different color. Let's just try to do 13 times 12. I'll slide it. So let's just try to do 13 times 12. And then divide it by 2 centimeters times 3 centimeters. So this gives you 156 divided by 6, which is 26. And so it seems like there should be 26, but the hard part of this question is actually finding a way to break up the pan so that we can put 26 brownies. So the way we do that is we're going to draw the pan again. And I know it's not a perfect rectangle, but so 13 centimeters, 12 centimeters. And usually last time we filled the whole thing up and we made it a perfect rectangle, right? So we made this like, this is basically a 12 by 12 rectangle. This was 12 centimeters, this is 12 centimeters, if you think about it. But we're going to make a small rectangle. We're going to make a 10 by 12. We're going to make a 10 by 12. So what that means is we're going to break 13 centimeters into 5 columns of 2 centimeters, right? And then this is going to have 3 centimeters. So this is 3 centimeters. This is 2 centimeters. This is 2. This is 2. This is 2, and this is 2. So 1, 2, 3, 4, 5 columns of 2 centimeters. And then what we're going to do is we're going to place them we're gonna place it like this. The brownie's like this. Oh. So this gives you, well, this is all 20, right? So all of these are 20. 5 times 4 is 20. Because 5 brownies per row, 4 per row. And these are all 2 by 3. Remember, so like all these are 2 by 3 brownies, which is the size of a brownie. And so we have this extra space of 3 centimeters. So what we can do is it's 12 centimeters, right? So we can break this into 6. 3, 4, 5, 6. And each of these are 3 by 2. So we're just like rotating the brownie. So there are 20 here, and then in the last column, there's 6 times 1, which is 6. So in total, there's 20 plus 6, which is 26 brownies. And so you guys might be thinking, okay, how do you come up with that? Like, what's the motivation behind doing this versus doing the original one? So what you always want to do is in these kinds of problems, the first step is try to find the maximum. So do like the area of the pan and then divide that by the area of one brown. Right? So area of the pan and then divide that by the area of one brown. So once you do that, then the next step is try to find a configuration that has this find a configuration. So those are the first 2 steps that we should do. All right, this was a like a pretty tough problem. For those of you that got it, a great job. And a lot of you figured out later, so that's great. Are there any questions so far? Any questions? All right, well, I'm not getting any messages or no one's saying anything, so I'm gonna assume that everyone understands it. And actually, right now, what we're gonna do is we're gonna have a poll. So I'm gonna ask you guys a poll on how fast you think I'm teaching. So do you think I'm talking too much? Am I going too slow, too fast? So you guys let me know in this poll. All right, and the poll should be live. I just launched it in the Zoom, so all right. I think everyone Everyone responded, so getting a little bit of everything, but most people are saying it's I'm teaching kind of slow right now. So I will pick up the pace. Let's do that. Um and all right. So let's just go to the next problem, um, which is over here. All right. I think I want to actually stick to 5 minutes. So each problem we're gonna give like 5 minutes and then I'm gonna explain because it seems like if I give more than that, the people are saying I'm waiting too long. So let's just do that. Okay. So if you guys notice, sorry to interrupt those who are problem solving, but I just sent a message. So if you guys could react to the message if you have learned geometric series, because if a lot of people haven't learned it, I'm gonna skip this problem because you need the knowledge of geometric series to solve it. And but I can always come back to this at the end of the seminar. So okay, it looks like some people have. For those that have, um, okay, by react, I mean if you hover over my message, you'll see a little emoji face. Could you guys put a thumbs up? So like I put a thumbs up. Just like could you guys click on that thumbs up if you've learned it as well? So I put a thumbs up. Okay, it looks like another person did. Or it looks like some people have, but most people haven't. So I'm gonna skip this problem, but it is a pretty good problem. If you want to work on it on your own, you can. But we'll just move on to the next one. So we'll skip this one too. Let's go to this one. All right, let's try this problem. Example 1.5. All right. All right. So a lot of people got this one, which is really good. Um, I'm gonna pick on Euclid. Do you want to share like not exactly what like the exact steps, but your general strategy to solving this problem? Euclid, can you hear me?
Yeah, I can hear you.
So what was your general strategy to solving this? Did you like
I kind of like got some paper and like plotted it out.
all right, that's always good. Okay. So I think that's a great strategy. So let's also do that. But I'm not going to be too exact because I just want to show you guys how you can actually do it without having to be really precise. So if we plot it out on the plane, we'll see we get something like this. So 3, 3, 3, 18, and then 16, comma 3. So our triangle looks something like this. And what kind of triangle is this? Is this a right triangle, an obtuse triangle, an acute triangle? What can you guys just tell me in the chat what kind of triangle is this? Just you can tell it to everyone. Okay, right triangle, right. Okay. Yep, it's a right triangle. And because it's a right triangle, all we need is we need this length. We're gonna call it L. And the height. And so we do length times height divided by 2. That's pretty straightforward. So the length is, well, 16 minus 3 is 13, right? And then 18 minus 3 is 15. So our area really is our area is 15 times 13 divided by 2, which is 195 divided by 2, or 97.5. And a lot of you got 97.5. For some reason, a lot of you got some of you got 144. I'm not too sure. I'm not sure what the thought process was there, but then you guys corrected it yourselves, so that was really good. And yeah, it's a pretty good problem. Any questions? Again, just let me know in the chat, or you can like interrupt me if you have a question. So let's move on to the next one. Okay, yep, 195 over 2. All right, this is also a good problem. So yeah, example 1.6. All right, this problem, a lot of people figured it out as well. And for this problem, I'm gonna call on Munil. So Munil, what was your thought process on solving this problem?
Um, I would just like find the fraction that are green and white, and then just use that to find the green.
Okay. So that's certainly a valid strategy. And I'm gonna show you guys the algebra way. So Munil's way is perfectly valid, but I'm gonna show you guys the algebra way, which is, let's say T is the total number of toys, right? So we have T toys. And so what are they saying? Well, they're saying half of the toys are black, so one half of T is black. So this is black. And then plus a fourth of T, so one fourth T is gold. And then five toys are green. and 4 toys are what? And this is equal to t. So this is an equation in one variable. So we solve it normally. We combine these two, right? So if we combine these two, we get 3/4 t plus 9 is t, which means t 1/4 t is equal to 9. And so the total number of toys is 36, right? 36 toys. But that's not what the question's asking. The question's asking for the fraction of the toys that are green. And we're given 5 toys that are green, so the answer is 5/36. A lot of you solved this one instantly. You probably did just like 1/2. You probably did 5/1/2 plus 1/4 plus or something like that. But either way, this is what you get. And yeah. Are there any questions on how you guys solve it? On how I did it. My bad. Any questions on the solution or the approach or anything? All right, no questions. That's always great. So let's move on to the next one. Yep, 5/36. And okay. This one is a little bit tougher, and it also requires a knowledge of geometric series. And some people know it. So if we finish this early, what I'm going to do is I'm actually going to solve the one we skipped, which is somewhere up here. I think it's this one. Yeah, we skipped this one. I'll go through this one and then we can try to solve 1.7. But let's go back to 1.7. Okay, so we'll skip this and let's go to 1.8. Okay. So you guys try to solve 1.8. All right, so a lot of people figure this out eventually. Some people need multiple tries, but that's okay. For this problem, I think I'm gonna call on who should I? Let's see. Adrian, do you want to explain your your approach to this problem?
Sure. So the number of degrees in a something sided shape is the number of sides minus 2 times 180.
Hmm.
So you just do 14 times 180 divided by 16.
Okay. So yeah, the formula that Adrian was referencing is the total number of so the total degree sum, right? Total. So the total degree sum of the angles is it's going to be 180 times 16 minus 2. And that formula comes from if you have an n-sided polygon, then the total degree sum is going to be 180 times n minus 2. And using this formula, we get that it's going to be 180 times 14. If you guys want to look up the proof for the derivation for the formula, I think we cover it in our Mustang Math Intro to Geometry class. So if you're not in that, you can always search it up. Like why is this true? But we don't have the time to go over that right now. Um, so but if any of you are interested, you can always like search it up. Anyway, so this is a total degree sum, and we want the measure of each interior angle, which means that we have to take this and then divide it by 16, right? Because there's 16 sides. And so when you do this, you just do the math and you get 157.5. This was a pretty straightforward problem. If you knew the formula, if you didn't know it, it's definitely a lot harder. But yeah, so that's how you do this one. All right. And let's go to 1.9. Let's see. This one's pretty tricky, but yeah, give this one a shot. If you don't know what a parabola is, you can message me. You can private message me. Um, so I can explain it to you if you don't know what a. All right, so I'm getting a lot of questions in the chat about like definitions or what does tangent mean, stuff like that. So it seems like this is a pretty difficult one also. Um, let's try the next one then. Let's try 1.10. I know it's I know like two or three people are working on it. If you are, I'm really sorry. You can always work on it. Like if you finish the next one early, you can work on 1.9 and then tell me the answer on 1.9. I can verify it for you. But yeah, we're gonna have to move on to the next one. So let's move on to 1.10. Yeah. I think this problem is it's a pretty good problem. So try this one. All right, looks like most people have got this one. Um, so for this one, I'm gonna call on Ashna. So Ashna, what was your methodology or like your approach when solving this problem? If you don't want to share, you can message me and I won't call on you. But okay, so okay, their microphone doesn't work. Um, but I'm just gonna go over it. So we see that we have a pile of cubes and we're dividing it into certain number of groups, right? So we can divide it into 13 equal piles. So if C is the total number of cubes, then C is a multiple of 13, right? Multiple of 13. A, right? And we also know that when we divide it into 11 cubes, 3 remain. And when we divide into 15 piles, 1 cube remains. So the best way to do this is to just go through all the multiples of 13. So we have 13, 26, 39. And so what you do is with each multiple, which each number, you divide it by 11 and 15 and check the remainder. So 26 divided by 15 is 2 remainder 6. So that's no good. We want for 15 we want a remainder of 1, and for 11 we want a remainder of 3. So we just go through all of them, and then we find that the smallest one is 91. 91. So 91 divided by 15 will give you 6 remainder 1. And then 91 divided by 11 will give you 8 remainder 3. For those of you that know modular arithmetic, what you'll see is that C is congruent to 0 mod 13. If you don't know it, that's perfectly fine. Um, Either way, this is the main approach you have to use. C is congruent to 1 mod 15, and C is also congruent to 3 mod 11. And if you know basic operations with mod, you you can solve this congruence, and you'll find that these two congruences will give you C is 91 mod 165. I'm not sure if anybody used this. If you did, great job. But I'm assuming most of you probably use the guess and check method. And even with this, it takes the same amount of time to do both. So yeah, there's that. But that's the general method. This one was mostly go through each multiple of 13 and just try it out. All right. And as always, any questions? Any questions over here for this question for this problem? All right, no questions. So what I'm gonna do is I'm gonna give you guys a 5 minute break. So we'll come back at 4:15 PST. So I'll write it here. We'll return at 4:15 PST, or if you're in EST, that's 7:15 EST. Basically, just be back in 5. Yeah. So yeah, 5 minute break for you guys, and yeah, see you guys in 5 minutes. Right. So welcome back everyone from our little 5 minute break. So we're gonna resume now. And yeah, so we just solved 1.10. We're gonna skip 1.11 and we're gonna go to 1.12. Because I think some students aren't being challenged enough. So let's try like a more difficult problem. So here's 1.12, and you guys give it a go. Think about the properties of a rhombus for this one. So I know this one was a pretty tough one. I didn't get too many responses, but I'm gonna call on Ayan to share with us what was your main takeaway with this problem? What was something what was the key insight that helped you solve this problem?
So like basically we know that diagonals in a rhombus bisect each other at right angles. So then you have like four right angles, and then you already know like one diagonal has length of 10, so one leg of the right triangle is 5, and then you can just put a variable for the other one and solve it.
Yeah, that's great.
Right back.
So we're gonna do what Ayan said. Um, one diagonal has length 10. So if we say this long diagonal has a length of 10, then it's bisected, right? So both of these are gonna have length 5. This is a property of rhombi. So if the odd diagonal has a side length of x, then that means that each of these smaller lengths are going to be x over 2, right? And from the Pythagorean theorem, we can think of trying to like pull out this right triangle. So if we pull out this right triangle, we get x over 2, 5 and 9, and we have a right angle. And this is classic Pythagorean theorem. So x over 2 squared plus 5 squared gives you 9 squared. And this means that x squared over 4 plus 25 is equal to 81, which means that x squared over 4 is 81 minus 25, which is 56. So x squared is 224. And yeah, that's our answer because we want to find x squared. So yeah, that's how you do that one. Any questions on this problem? All right, I'm not getting any questions, so let's move on to the next one. Um, yeah, let's go to 1.13. Okay, 1.13. All right, a lot of people got this one. Yeah, a lot of people got this one. So let's see, for this problem, I'll call on Euclid. You want to explain how you did this one? Like, what was one key insight that you used to solve this one?
Okay, so the way that I solved it is that like first we have to place like Emily and Seabiscuit because like they're like kind of like the important one. So I know there's like 8 ways to do that, right? Since like there's 5 spots and like have to be together, so like you gotta be on like 1 and 2 or 2 and 3 or 3 and 4 or 4 and 5. But then you can like turn like reverse the order of them.
Right.
So nothing
Right. Okay, and then you arrange the rest of them. Great. So that's definitely a way. Um, but I want to show you guys a different way that's like generalizable to more complex problems. So what I mean is, let's say we have the five folds as A, B, C, E, S, right? Emily and C basically are E and S. So let's put a block around these people. So A is going to be a block, and then B is going to be a block, and then C is going to be a block. And E and S have to be together. So ES is going to be one block, right? We can call this block one, block two, block three, block four, right? And how many ways are there to arrange four blocks? Well, that's just 4 factorial, which is 24. And some people said it's 24. But the thing is, within the block, there's 2 ways to put E and S. So there we could have ES as one permutation or SE as another permutation. So we actually have to do for each one of these 24 blocks, we have to multiply by 2 because there's for each block, there's 2 ways to order Emily and Seabiscuit. So the answer is actually going to be 24 times 2, which is 48. And yeah, but a lot of people got 48. So great job. And I can tell that even for those who got it wrong, you guys were able to like figure it out. But yeah, this was a good problem, and let's go to the next one. So this is gonna be our last problem in section one, and then we're gonna move on to section two. 1.14. Okay. Actually, this one I think we're gonna skip this one, so let's move on to section two. Because this one's pretty straightforward. Like you can probably answer it just from seeing it. So let's move on. Yeah. And people are already telling me the answer to the problem. So yeah, this one's pretty quick. Let's go on to section two. For section two, let's start with um let's go to page 39. Okay. Yeah. This is an interesting problem. Let's go to this one. Yeah. It looks like people have got this one. So I'm gonna call on Shane to explain what was your key insight to solve this problem.
So for most of the squares, it's either if you add one to them, they become like prime for some of them, and um and if you like add one to other ones, it kind of just doesn't work.
That's a great observation. Yeah, that is a great observation. So if we go by Shane's point, we see that 2 squared plus 1 is 5, which is prime. Um, even 4 squared plus 1 is 17, which is prime. And like 6 squared plus 1 is 37, which is prime. So that's a great observation. And then you go through all of them. You could probably go through the first 10 and kind of get a sense that okay, none of the first 10 are working except for n equals 1. So like what's going on here? So let's try to unpack it in a more like formal way. So n squared plus 1 is n squared minus 1 plus 2, right? We all agree with that. And so if you guys know the difference of squares, what n squared minus 1 is n plus 1 times n minus 1. So I'm going to write this equation like front and center. So n squared plus 1 equals n plus 1 times n minus 1 plus 2. So if you divide both sides by n plus 1, we get that n squared plus 1 over n plus 1 equals n minus 1 plus 2 over n plus 1. So why am I doing all this algebra? Well, what we want is if n plus 1 is a factor of n squared plus 1, which means that n squared plus 1 is divisible by n plus 1. That means that this side has to be an integer, right? Let me use a different color. So this side in blue, over here, this side has to be an integer. The right side also has to be an integer, right? Because if the left side is an integer, then the right side is also an integer. And so if the right side is an integer and the left side is an integer, well, we know that n minus 1 is an integer, right? So that's pretty good. The thing we have to worry about is the fraction. So 2 over n plus 1 is an integer. So if 2 over n plus 1 is an integer, like a whole number, right? Integer. Well, let's try it. Let's just plug in a bunch of n and see what happens. Well, if n plus 1 is too big, so let's say if we plug in n is a million, let's say just pick a really big number. So like 2 over a million and 1. Like a million with a bunch of zeros. That there's no way that's an integer, right? That's way too small. Like 2 over a really big number is gonna be a really small decimal. There's no way it's an integer, right? So what I'm trying to say is that n plus 1 must be less than or equal to 2, right? If the denominator is bigger than the numerator, like 2 over 3 or 5 over 19, then that number is going to be less than 1. And there's no positive integer less than 1. So what we have to do is we have to set n plus 1 less than 2, equal to 2, which means n is less than or equal to 1. But guess what? The only positive integer less than or equal to 1 is 1. So the only solution is n equals 1. And that means the sum of all possible n is n equals 1. So this is just a way of taking Shane's argument, like Shane's observations, and then writing it in like a proper math notation. Like, why is the answer only n equals 1? So yeah, great job, Shane. Great job, others who were able to get it. And I thought this was a nice problem to show you guys. how to like think outside the box a little bit. Let's see. Let's try 43. So 43. And after 43, I'm gonna go back to 1.3, 1.7. I skipped geometric series, but I think for those of you that don't know it, I think this is a good opportunity for me to teach you guys. So let's go to 43. And yeah. So try this one, example 2.7, and let's see what happens. All right, for the sake of time, I'm going to we're gonna go over this. So I'm gonna call in Euclid. What was your key insight to solving this?
Okay, so my key insight was just like testing like smaller things. So basically all we need to find is the numerator of this fraction. So for 1 1 it's 1, and for 2 1s it's 0, and for 3 1s it's 1, and for 4 1s it's 0. And I noticed that when there's an odd number of ones, it's 1, and when it's an even number of ones, it's 0.
That's right. Okay. So That was a great explanation by Euclid, and let me show you guys what he's talking about. So if we go over here, yeah. So if we have 1, 1, that's just 1/2. If we have two ones, 1 minus 1 over 2 is 0. Plus 1 minus 1 over 2 is 1 minus 0 over 2, which is 1/2. If we have 4, we get 1 plus 1 minus, oh, sorry, I mixed it up. So it should be 1 minus 1 over 0, which is 0 plus 0 over 2, 0. And so we notice that if we have an odd number of ones, then the fraction is going to be 1/2. If it's an even number, then it's going to be 0. But let's talk. So this is what we call, in math, we call this like a conjecture, right? We test a bunch of cases and we make a conjecture. We say, okay, I think this is what's happening. And the hard part is you have to say, okay, wait, why? Why is this true? So let's go through it. So 1 minus 1 plus 1 minus 1 and so on. Let's say we have an odd number, right? And so 1 minus 1.
This is a reminder. Sharpen your school pencils.
1 minus 1 plus 1 minus 1 and so on. And let's say if it's odd, then we're going to end on a plus 1, right? We're going to end on a plus 1 if we have an odd number. So every minus 1 and plus 1 is going to cancel out. So minus 1 plus 1 cancels out. Minus 1 plus 1 cancel out. And so everything will cancel out. And this last plus 1 will also cancel. And so we'll be left with 1/2. If we have an even number, we're going to end on a minus 1. So even number, we're going to go 1 minus 1 plus 1 minus 1 plus dot, 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 dot. And then we're going to end with another plus 1 minus 1. And so each sort of 1 minus 1 portion is going to be 0. So in reality, we're just adding a bunch of zeros together. And so what we end up with is just 0 over 2, which is 0. And we have 111 ones, and that's an odd number. And the common fraction is a over b. And so 1 plus 2 is 3. So our answer is 3. And yeah. Any questions on that? On how I did it, like on the solution? Okay, so no questions. Let's go back to those two problems that we skipped that were geometric series. I think everyone here said they know. Some people left. So when I say everyone here, what I mean is the people who are still in the meeting. Let's go to 1.3. Okay, so 1.3 is page 6. Yeah, so you guys can give this one a shot. If we have time, we'll go for 1.7. 1.7 is pretty tough. But I think we have time to go over it. So for the sake of time, we got like 10 minutes left. So I'm gonna explain this one and then I'm gonna explain 1.7. So originally we're at $15. So $15. And then what we end up doing is we increase by 15% and then we decrease by 15%. So let's we gotta have a scale factor, right? So every geometric series has a common ratio R. Um, and a starting term A. So here A is 15, right? That's pretty clear. We start with $15, so A is 15. And the tricky part is finding R. So R is between 0 and 1. So the absolute value of R must be less than or equal to 1. Don't worry about absolute value too much. Here we're only dealing with positive values. So let's just go through. Let's just go with that. So when we increase by 50%, we multiply by 115 over 100. And then when we decrease by 15%, so in the morning it increased by 50%, and then in the afternoon it decreased by 50%. I think this is also a good opportunity to clear up like a misconception, which is if you increase something by 15% and then decrease by 50%, it does not go back to the original. So if we have $100, or like in this example, if we have $100, we increase by 15%, then we decrease by 50%. We're gonna have $99.25 or around that number, not $100. So going back here, we multiply by 115 times 100, and then we multiply by 85 over 100. Because when you decrease something by 15%, you multiply by 85 over 100. So when you do this math, what we end up is we see R is equal to 0.9775, right? So every day we're scaling down by 0.9775. And so here's what a geometric series looks like. So if we call it series S, we get S equals A plus AR plus AR squared plus dot dot dot. And this goes on forever. So it's an infinite series. And the way we solve it is we multiply S by A. So we get by R, sorry. So we get RS equals AR squared plus AR plus AR squared plus AR cubed and so on. What we can do now is we can say, okay, if we do S minus RS, so we subtract this whole thing, AR cancels out, AR squared cancels out, and everything, because it goes to infinity, so we say everything cancels out. And so 1 minus R times S is equal to A. That means that S is equal to A over 1 minus R. And R satisfies the condition here that absolute value of R is less than 1. So what we do is we say S is equal to, when we plug in our values, we get 15 over 1 minus 0.9775. So we do that, and this gives you 2,000 over 3. And I think Shane and Euclid got that. It's a great job. And to close off the session, let's go over 1.7. I don't think we'll have time to solve it, but let's just go through it. Because for those of you that know geometric series, this is a good advanced problem to solve. So what we're doing here is we're given a function and we want to find f of 1615, right? Let's just first plug that in, right? So f of 16 over f of 1615 is equal to 1 over 16 plus 2 over 16 times 15 plus 3 over 16 times 15 squared. And you notice the pattern is we increase the numerator by 1, and then we increase the power of b by 1. So this will be 4 over 16 times 15 cubed, and we go on forever. What we're going to do here is we're going to pull out 1/16, okay? So this is equal to 1 over 16 times 1 plus 2 over 15 plus 3 over 15 squared plus so on, right? So let me pull out this parentheses term in red. So I'm gonna pull this out and we're gonna call this S. So just like we did with the other problem, we're gonna say S is equal to 1 plus 2 over 15 plus 3 over 15 squared plus 4 over 15 cubed plus so on. And we do the same thing. So we say, what's our R here? Our R is 1 over 15, right? So we multiply S by 1/15. We get 1/15 times S is 1/15 plus, let me actually shift it. So I'm gonna write a 0 here. So we 0, right? We can add a 0 to anything. So 0 plus 1/15 plus, sorry, yeah, wait. So 1/15 plus 2 over 15 squared. And if you're wondering where I'm getting these numbers from, it's like, this is like how many. So I'm multiplying the numbers diagonally plus 3 over 15 cubed, right? So like that. And go on forever. And the reason I wrote that 0 there is because now we're going to subtract these. And it was pretty clear how the subtraction works. We get 14 over 15s is equal to 1 minus 0 is 1. And then 2/15 minus 1/15 is 1 over 15. And 3 over 15 squared minus 2 over 15 squared is 1 over 15 squared. And this is plus 1 over 15 plus 1 over 15 cubed, right? And so on. But hey, what is this? This on the right-hand side, this is our classic geometric series. And in 1.3, we found that it's equal to A over 1 minus R, right? So our A here is 1. So we get 14 over 15s equal to 1, our starting term, divided by 1 minus 1 over 15. So what we're able to do here is we're able to say, okay, this is equal to, so 14 over 15s is equal to 15 is equal to 1 divided by 14 over 15, which is equal to 15 over 14. So S is equal to 15 over 14 times 15 over 14, which is 225 over 296. But remember, we just found S, and S was this whole big parentheses term. What we want is 1 over 16 times S. And 1 over 16 times S is 1 over 16 times 225 over 296, which is 225 over 3136. Oh wait, 14 times 14 is not 296. 14 times 14 is 196. So then 225 times 196 will give you 2136, right? 6. Okay. So finally our answer is going to be 225 over 3136. But yeah, that's how you do this one. I wanted to get over the more familiar ones in the beginning. But yeah. And for those of you who are still there, I'm gonna put out a final poll, which is all right. I just relaunched the poll. If you guys could, all you guys have to do is, and now that the lesson's done, you guys can give any feedback on how you think the lesson was. And once you're done with that, you guys are free to leave. Thanks so much for joining. Um, and yeah, stick around if you have any questions. But yeah, once you guys fill out the form, you're free to leave. And I will post the recording and the handout in the Google Classroom. So